Welcome to a special Desmos edition of Solving Hard SAT Math Problems. Desmos is a very powerful tool that makes life much easier during the SAT. Today we will solve some problems exclusively using Desmos. Let's get started. The first problem deals with a couple of inequalities, and we have to find which of the ordered pairs is a solution to the system of inequalities. So we will type in the first inequality, which is y is less than 1/2 x plus 4. We can already see that Desmos is doing its job and highlighting this inequality in green. Similarly, we'll plug in the second inequality, which is y is greater than negative 2x plus 4. Okay, so as you can see, the green portion is for the first inequality, and the purple portion is a solution for the second inequality. So the easiest way is to now plug in the options and see where these ordered pairs fall in. And what we want to see is the ordered pair falling in this region, which is overlapping the purple and the green regions together. Okay, so let's look at the first ordered pair. This is 0, 2. And you can even label these ordered pairs so that you can keep track of it. So let's label that A. The second one is 1, 0. And that's going to be B. The third one is 1, 5. And let's label that C. And the last one is 2, 4, which is going to be option D. Okay. You can see that A and B fall only in the green region, which means that they satisfy only the first inequality, and C falls only in the purple region, which is the second inequality. But option D falls in the shaded region of both purple and green together, which means it satisfies both inequalities. So option D is our answer. Our next problem deals with a couple of equations again, and here we have to find a value of A where the system has only one exact distinct real solution. Okay, so let's start by plugging in the two equations. This is y equals -3. And the second equation is going to be y equals x squared plus 10x plus a. Okay, now when you put in a constant as a here, automatically it will say add a slider. And the slider's default value is going to be between -10 and 10. So let's see what happens when we move it one way or the other. When we're moving it to the left, our vertex is going down. We don't want it to go down, we want it to go up. So as we're moving it to the right, all the way to 10, our vertex has moved up, but we haven't really touched y equals -3 line here. So what we need to do is we need to change the bounds of the slider. So let's make it -50 to +50 here. Okay, and we don't need to do anything to the step. So now as we increase further and further, we will also zoom in, and as we're getting closer, right here at a equals 22 is where both these graphs are meeting at a single point. And so that's going to be our answer, which is a equals 22. Our third problem is from the geometry and trigonometry portion. And here we're given that a circle has a center at 4, -5 and a radius of 2. And another equation is given where this equation and the equation of the circle with the center and radius given is going to be the same. And we have to find what is the value of c, okay? So the first thing that we should do is we should put down the equation of the circle with the center 4 comma negative 5 and radius 2. So that will be x minus 4 square plus y plus 5 the whole square equals 2 square. So this is the equation of a circle. Let's put in that equation here, and we got a circle here with this equation. Let's zoom this in. And this circle has to match the equation of the circle that's given in the problem, which is x squared minus 8x plus y squared plus 10y plus c equals 0. Okay, so nothing has shown up. The reason nothing has shown up is we haven't selected a slider, and we have to select a slider by clicking C here, and you can see that the red circle is a bigger circle because C right now is just 1. And when we start changing the C value, increasing the C value here, the red circle starts becoming smaller. We're having the same problem where the sliders bounds are negative 10 to 10, so we will increase that. Again, let's make it negative 50 to 50. And we were at 10, so let's keep increasing the value for C. And as we're getting closer and closer, let's zoom in, and we should be getting very close. Okay, so at 37, C equals 37, we only see one circle because they have become a single circle. So if we get rid of the red equation, we only have the black circle here, and when we get rid of the black, we only have the red one. So C here is going to be 37. So that's our answer.